Welcome to Vision Plus and welcome back to this Singapore Mathematics on Complex Numbers. We are now doing example 5 under argument of a complex number. Example 5 says that you need to find the principal argument of the following. Part A, Z1 is given as 3. So we need to start by illustrating Z1 on the Argand diagram. This 3 is the real part of the complex number Z1. That means the imaginary part is 0. So this complex number Z1 was in this form and 2 was 3 plus 0i. So let us draw the Argand diagram to represent that. This is the imaginary axis of Z1. This is the real axis of Z1. This is the origin. Now we have 3 on the real part. So 3 is here. The corresponding negative 3 is there. Also, since the imaginary part is 0, let us just mark 3 here and negative 3 there. Now we need to locate this complex number, which is 3. So the real part, we have 3 here, and the imaginary part, we have 0 on the imaginary axis. So 0 and 3, they are coming to meet here where 3 is. Because this vertical line, which is the imaginary axis, is flexible. As long as it is on the real axis, the value of the imaginary part is 0. Remember your properties that on the x-axis, which we are saying maybe on the x-intercept, y is 0. On the y-intercept, x is 0. It's the same property. So they are coming to intersect here. This is where the arrow is. This is the complex number Z1. Now, how do we measure the angle? Remember, we are supposed to measure the angle from the positive x-axis, but the complex number is lying on that same line. Okay, it's lying on that same line. That means we are going to move by 0 degrees. They are on the same line. It is like if 2 points are together, or if 2 things are touching here, what is the distance between them? Okay, by what units do we need to move from this finger to the other finger when they are attached together? It is 0. So the angle that we need to move from the real axis, which is the positive x-axis, to where the complex number is 0, because they are together. They are together. Therefore, theta is going to be equal to 0 degrees. It is going to be equal to 0 degrees because there is no distance that you are going to move. Therefore, it is in this range. Negative 180 into fall to 0 and then goes to positive 180. So it is the principal argument. Principal argument. So the argument of Z1 is 0 degrees. And that is the answer. Now going to part B. Part B says that we are given a complex number Z2 as I minus root of 3. So we illustrate on the Argand diagram. This is going to look like that. This is the real axis of Z2. This is the imaginary axis of Z2. This is the origin, center 0. Now, this is the real part of the complex number, negative root 3. I is here. So negative root 3, assuming it is here negative root of 3, then we plot here corresponding positive root of 3. And then for the imaginary part, there is coefficient of 1 here. That means 1 is somewhere here and negative 1 is somewhere here. Remember, root of 3 is like 1.8 something. So these two values are very close. Root of 3 is 1.73. So we just estimate. So this root of 3 should be further, slightly away from origin, but there's not so much penalty. They are very close. Now from here, the imaginary value here, the coefficient of I is 1, which is positive 1 is here. And for the real part of the complex number is negative root 3, which is here. So we look for where they're going to meet. That format. They are meeting somewhere there. Get your ruler, goes to a line from the point of intersection to the origin, or from origin to the point of intersection, or like that. Then we put an arrow on top here. Then we say this is my complex number Z2. Now the question was asking for the principal argument. So we say from here to here is the argument of the complex number theta. After getting theta, then we go on and judge. Is it in this range? If yes, it is a principal argument. If it is not in that range, then we get the one corresponding to that range. What do we know already? We know that this angle of 90 degrees, this right angle here is 90 degrees. So what we need is this small angle here, so that we add it to 90 and it gives us the argument. So I'm going to extract this triangle from here to here, here and there. That's why it has dotted line, vertical is clearly solid, complex number is there. This one has formed a right angle triangle in that format. This is the single angle that we are looking for. Let me call it any angle, let me call it B. Now we need to indicate the distances from here up to here is the same as from here up to here, which is negative 3, which is negative root 3. But we are taking the number of units, which are going to give us root 3 units. Then from the origin up here is 1, and origin up there is 1. So this side is 1. So this is where our angle is. Opposite to the angle is root 3. So this side becomes the opposite. This side becomes the adjacent to the angle. This side becomes the hypotenuse. Then we apply our SOHCAHTOA. SOHCAHTOA. We cannot use sine because there is no hypotenuse, even cosine there is no hypotenuse. But you could go on, find the hypotenuse, then you apply either sine or cosine, and we shall get the same answer as using tan, for which the opposite and adjacent are given. So therefore, we shall say here now tan of the angle we are calling B, which is given by opposite out of adjacent. Then we substitute, so that here we have tan of B equals to, what is the value of opposite? Opposite to the angle is root of 3 divided by adjacent, which is 1. Root 3 divided by 1 is root 3. So that if I say both sides by tan, so that I have arctan or tan inverse of root of 3. Root of 3 divided by 1 is root 3. So what is tan inverse of root 3? It is 60 degrees. I'm getting here 60 degrees. So this small angle here we have called to be 60 degrees. That means this one here is 60 degrees. So let us get our argument now, which we are calling theta. Now this theta here becomes that 90 degrees plus 60 degrees. This here now gives us 150 degrees. Plus 90 degrees is 150 degrees. Now this is the argument we have got. Now let us judge. Is it principal argument or not? Is it in this range? Negative 180 degrees to 180 degrees. Yes. 150 is somewhere here below 180 degrees. That means that value is for the principal argument. So therefore, principal argument, we shall now say the argument arc of Z2 is 150 degrees. So argument is simply for the angle. But if the angle falls in this range, we now say principal argument. If it is outside the range, we call it argument, and then we shall go on and we find the angle that falls in this range for us to call it the principal argument. But there is no penalty to the students at this stage of education. So this is part B. Let us go to part C. And now going to part C. Part C which says that Z3. What is Z3? Z3 is given as 2 plus root of 5I. So we're going to let's draw this on the Gann diagram. So we draw the axis. This is the real axis of Z3. This is the imaginary axis of Z3. And then we have 2 and 5. 2 is on the real part, which is here. That means the corresponding negative 2 is there. Root of 5 is like 2 point something, which is bigger than 2. So we make it farther away a little from the origin. This is root of 5. Then this is the corresponding negative root of 5. Then we plot. We have positive 2 on the real axis, which is here. Positive root 5 on the imaginary axis, which is there. So we look for where they're going to meet, somewhere there, which is there. Then you get your ruler and draw a straight line from origin up to that point of intersection. Then you put your arrow on top. Then you mark that this is my complex number Z3. Now let us go to the part of argument. Argument now becomes the angle from the positive x-axis up to where the complex number is later. Now this angle is going to be small. I'm saying that it is less than 90 degrees because from here up to here is 90, but now it is somewhere here. That means it is less than 90. So we need to extract that small triangle again from the origin to the tip of the complex number and back down here and there. So extracting that looks in this format. We have that vertical line, we have this line and that line. Here. This is where our right angle triangle forms. And now we are going to look for this small angle here. That is our adjoint. Let me call it beta. Or you can call it anything you want, A, B, C, D, K, whatever letter. That's for you to find that part. And now from down here up to up there is the same as from down here to root 5. So this side is root 5 units. Then down here from origin up to this side is 2. That means here are 2 units. Now this is the angle we are looking for. So opposite to the angle is root 5. So this side is opposite. Adjacent to the angle is 2. This side is adjacent. The longer side is always the hypotenuse. Then you apply your secant law. So sine will meet hypotenuse, cosine will meet hypotenuse, but tan we have opposite and adjacent. But you are free to first go on to find the hypotenuse, then you use the hypotenuse to find the angle, either using sine or cosine. But since we have the opposite and adjacent, let us just say therefore we have tan of the angle now which we are saying beta given by opposite out of adjacent. Then we substitute so that here we have tan of angle beta equals to what is opposite, root of 5 out of adjacent is 2. That means now beta now becomes the arctan or tan inverse of root of 5 out of 2. Then you put your calculator. Tan inverse of root of 5 divided by 2. I'm getting 48.19. 48.19 degrees.